welcome to Test Cross channel. Please, before we move on, do well to subscribe to our channel uh, so that you can get updates when we release more content. So in this video, I'll be teaching you about provisioning a persistent EBS-backed storage on Amazon EKS using Helm. So before we go on, there are some prerequisites that you need to accomplish, such as you need to have AWS CLI installed on your machine, as well as the EKS CTL utility and also the Helm utility. So when you have that installed on your machine, you can go on to the next task. So the first task is to create an EKS cluster. So you create a file and name it demo cluster.yaml, uh, and then paste in this YAML configuration into it. So we name our cluster the demo cluster in the US West 1, and then we would have two node groups, each having T3 micro instance type and the minimum of one uh, worker node and the maximum of two. So you copy that and place it in the file. For in my case, I have that file already, which I've put in the YAML file. So I will go ahead to apply it. So I'll apply the to create my Kubernetes cluster, and that is going to take a little bit of time. So what I'll do is I'll simply go ahead to pause the video. All right, so our Kubernetes cluster has finished provisioning. We could actually confirm that by running kubectl get nodes um, to confirm that you can see we have the two worker nodes that uh, two worker nodes that we provisioned, right? And the status is ready. We can also go to the EKS platform to see the cluster that have been created. Our demo cluster has been created, right? And when I click on it and I click on compute, we can actually see, where is it? Compute. Okay, we can see the two node groups that were provisioned, right? And and both of them are active, right? So those are the two node groups, managed node groups that were provisioned. So the next task, now that our cluster is ready, the next task is to create an IAM OIDC identity provider. So to do that, first of all, you may want to check whether you have the the OIDC provider already existing in your account. But in my case, I don't have, and which I doubt. So since your cluster you just created it, you won't have one. So, but if you want to check whether you have one, you could run these two commands. But in my case, I already have that, so I don't have it. So I'll go ahead to create it. So I'll also be using the uh, EKS command utility to create or to provision the IOD. So I will go ahead to use the EKS utility to create the OIDC provider. So while that is provisioning, so that has completed provisioning, I can view it. So let me copy this other command to be able to view it. Okay. So I want to view my OIDC uh, provider that was. So I put that as an environment variable, and then I run this other command to view it. So let me put that in. Okay, so we can see our OIDC provider. So take note of this particular ARN. We'll be making use of it very soon. So let's move on to the next task. So the next task is to configure a Kubernetes service account. to assume an IAM role. So we're going to be creating an IAM role, and before we do that, we want to create a service account. So you can go ahead to copy this YAML command to create your service account. But in my case, I have that already. So I'll simply run it. So this service account, I have that here. So the name for the service account is EBS CSI controller SA, and the namespace is Cube System, right? So I'll go ahead to apply that. So Cube CTL apply, okay, apply service um, service accounts dot YAML. I hope I got that right. Let me check. Okay, yeah, that's right. So I'll run that, and that should create a service account. Just okay. So service account created, right? So the next task is to so you can go ahead to set your account ID as an environment variable, and also the UI. So I'll run this command to set my OIDC provider as an environment variable. I think I ran that earlier. Okay, yeah. So let me do that. Set that as an environment variable. Okay, I needed to change something. Yeah, that should be the region. So export. Let me export as AWS underscore region. I need to put that as an environment, but so I'm using the US West one. Okay, so done that. Let me now fix this in. My cluster is demo cluster here, so this should work. All right, yeah, so that's worked. I put that as an environment variable. So the next task is to set these variables. So your case, you can go ahead to do that. But in my case, I already done that. I already put the various values in the file. So the next task is to create the trust policy for our for our IAM role, the trust policy. So let's do that. So you can copy this and run it on your terminal. But in my case, I have the file already, the trust policy, EBS CSI driver trust policy. I have that already. So I will just need to adjust a few things. So I'll copy the OIDC number there. Um, I will simply copy it, and I will get that adjusted uh, quickly. So let me do that. Um, so I will also place it in the other one. Then for the final one here. So I have that adjusted. We'll save it. So now that it is saved, I can go ahead to to run the command to create the IAM role, and I will be referencing this trust policy that I created earlier. So let me do that. So AWS IAM, I'll copy that command. You can go ahead to change the description, add more description if you want. So in my case, I will simply go ahead to run the command. Um, so yeah, so I have created the role. So the role I named it, the name of the role is Amazon EKS EBS CSI driver role, right? So that's the name of the role, right? Amazon EKS EBS CSI driver role, right? So we created the role and we've associated the trust policy, which we have in this JSON file, associated it with it. And then the next task is to create to attach an AWS managed policy, to attach it to the role that we just created. So the policy that we are attaching is the Amazon EBS CSI driver policy, right? It's a managed policy by AWS containing a number of permissions. So we'll just associate it with our role, right? So but first of all, if you go to roles, you will see that we created the role already, which is the EKS EBS role, right? Currently, there is no policy attached to it. So let's do that. Let's run that command to attach the policy. So let me just clear my screen. Then I'll put in that command to associate the policy to this. So now that that has worked, that has run successfully, if I go ahead to refresh this, right, I should see my right. So you can see our policy, the Amazon EBS CSI driver policy that's now attached to our driver role, right? So the next task after doing that, the next task will be to annotate the service account, right? So annotate the service account. Then you can go ahead to place the account ID and the service account and all those other values. You could have put it in the in you would have put it in there. So I will just quickly adjust that uh, before we move on. So um, I will change the account ID here. Okay, I'll change that. So just a second. Okay, so moving on, I'll be copying that command again. This command so I'll put my account ID as an environment variable. All I'll do is to adjust that particular command. So let me do that quickly. So I'll be taking the the name for the service account we created earlier. I'll copy the name so that I can adjust the command. So um, the account ID is already in an environment variable. So I'll go and adjust the service account name. You can put it as an environment variable if you so prefer. The namespace is the cube system. Okay, so let me run that command to annotate the service account. So that has been annotated. So the next task, let's move to the next task. That should be adding the Amazon EBS CSI add-on, right? So that's EBS CSI add-on is what will enable your storage to be dynamically provisioned by AWS, right? So in this case also, we'll be making use of the EKS utility to do that. And I will simply just adjust uh, the cluster name. That's all we're adjusting in this command. So let me run that command. So I'll run it. That's to create the add-on, right? And so add-on, creating add-on. So while it's being created, if we go to our Kubernetes platform and go to add-on, Kubernetes cluster, and go to add-on, we'll see that our EBS CSI driver is in creating mode, right? And we could simply wait for that to finish creating. So while that is creating, could do a refresh. See, okay, right, still in creating mode. To take just a few seconds to finish creating. So let's just wait for that to finish creating. So the next task will be to update the worker nodes role. So the worker nodes role will need to be updated. Let me see. Okay, I'll need a little bit time. Okay, now it's active, right? It's active now. So yes, it's active now. So our CSI add-on, EBS CSI add-on is now active, right? So the next task will be to, add the EBS, Amazon EBS, EBS CSI driver policy. The other policy we attached to the role we created earlier. We are going to also attach it to the worker node. So I'll go to IAM. I'll go to the roles, right? The roles, the worker nodes that were created earlier by our EKS utility. So the two node groups roles that were created. So I'll be attaching, first of all, you should make sure you have these four uh, policies attached already. Then we'll go ahead to attach the EBS CSI policy to it. Okay, EBX. So this we'll be attaching this our to our cluster. So that has been attached. Let me attach to the other one. Okay, it is not there. Let's attach it as the EBS. Okay, so let's attach. And finally, let's also attach it to the service account, uh, service role for our Kubernetes control plane. So we'll do that EBS, and so I'll attach that. Okay, so I've attached that to uh, the three rows there. Now the next task will be to deploy the Postgres database using Helm. So we'll be making use of Helm to deploy our Postgres database, right? So, but before we do that, we'll define our storage class, right? It's define a storage class. So you create a file, name it whatever you want, but name it whatever you want, .yaml. This is a YAML file. Then you simply paste this into the YAML file and then apply it, right? Apply it using the cube CTL create apply command, right? So let me go ahead to do that. In my case, I already have that file. No, that's the storage class, right? This I already have it. So what this will do for us is that to create the storage class with this name, and this is the provisioner, right? This is the provisioner, and the type is the GP2, right? The GP2, and if you like, you can change this to 3, make it the type for GP3 type. So in my case, I'm making use of GP2, right? So what I'll do is I'll simply apply it, right? Um, so let me apply it, but I'll need to adjust this name. That should be, in my case, I have it as AWS PG SC. Okay, go ahead to apply that, right? So our storage class has been created. We can confirm by doing kubectl, kubectl get storage class. So if we run that, so we can see that our storage class has been created, right? It has been created, and the reclaim policy is the volume binding mode is immediate, meaning that it won't wait for the pod to finish creating before it gets created. So, but in my case, I will want to go ahead to delete the GP2, so I don't face any error while trying to use Helm to provision uh, to provision the storage. So I'll delete the GP2, right? So I'll delete it. All right, so GP2 has been deleted. So let's move on. Now the next task, I'll go ahead to install the Helm charts, right? So before I install the Helm chart, I will simply make use of. So first of all, I'll go to, okay. So let me search for Progress Helm chart. So Progress Helm charts maintained by Bitnami, right? So I go. Let me go to the GitHub repository for the Helm charts. So while that, okay, so we have that. So first of all, what we would simply do is to install, add the Helm repo, right? After which we'll install the Helm charts. And in my case, I already have the Helm chart installed. I have it added. So I will just simply go ahead to install it. So in my case, I have some values I want to overwrite in values.yaml. I want to overwrite some values here. So that's the reason why I created the file, right? I created the file values postgres.db.yaml, right? So that's why I have that file there, this file, right? So this file, the values progress db.yaml, I'm trying to I want to override the storage class, the default storage class that the Helm chart is coming with, right? The default storage class. I'm overwriting it to make use of the one I provisioned, which is the AWS PGSC, right? That was the name for my storage class. That was the name that I used to provision that storage class. Then I would also be overwriting the username, the password, and the database, right? So to do that, I will simply, so in my case, I'm, uh, I'm installing the chart with the release name PGDB, right? PGDB. So I'll simply copy this. You can go ahead to copy uh, the first command to add the the Helm repo to your machine. But in my case, I'll simply go ahead to install. I'm installing the Helm charts and I'm overwriting some values in the values.yaml, and such values are the username, password, the database name, and the storage class, right? So that will take just about a minute to provision. So when that provisions, we would now be able to check uh, for our the persistent volume claim, and the ports. And if that shows successful, if our persistent volume claim, if it shows as bound, if the status shows as bound, it means that our storage has been successfully created. And then if we run the kubectl get ports, if it shows status as ready, it means that our cluster has successfully, our pods are successful, our Postgres container has and the pod has successfully been created, right? So let me go and check if that has okay. So um, our Postgres database has been successfully deployed, right? We can now check for the persistent volume, get PV, um, right? We can see that we have the PV provisioned, and the status is bound, right? It's bound already. Let me clear my screen. Um, so the next, we can check for PVC, the persistent volume claim, and you can also see that that has been provisioned, and the status is bound. And we can also check for the ports. Yes, you can see that our pod is running, right? Our pod is running. So Having done, you can also check on the, so if we go to EC2, if we go to EC2 under EBS Elastic Block Store, if we click on volumes, we can see that we have our volume. So yeah, you can see that we have our volume created. If I drag this up, right, you can see that this is the volume created. If you see that, you check the name, right, this 52A, right? This last number is 652A, right? I just want to confirm that that is so 652A, right? You can see that our volume has been, provisioned. Our persistent storage on EBS has been provisioned, right? And then it is attached to one of the uh, worker uh, worker nodes, right? It is attached to one of the worker nodes, right? So uh, it has been successfully provisioned. The next will be for us to now do cleanup, right? So we've achieved our aim and we've been able to provision uh, a Postgres DB successfully running in our cluster, and then we persisted the storage on Elastic Block store in AWS, right? Just as we can see, right? You can see the details right here. Everything has been provisioned, right? So the next task will be to clean up. So to clean up, you can either run this command, but from experience, I found that the command would not usually, delete the cluster due to the presence of this pod or some other pod. So what I will simply do is simply go to the cloud formation, check the stacks. You will see the stacks that were used, the stack templates that were used to create to provision our cluster and the node group. So you could actually simply delete manually delete each of these, right? Because if you try to delete it through the command line, that might not work. So you can go ahead to delete it manually, right? And I think it will ask you to retain the node group the node group role that you created earlier. This to ask you to retain this, right? So you can go ahead to do that. Retain this, delete the cluster, and then come back and delete the rows, right? So that comes to the end of our demo on creating, provisioning an EBS persistent volume, persistent storage on Amazon EKS using Helm. So I hope you enjoyed the video. Feel free to comment below if you successfully provisioned that on your local machine. So thank you for watching. See you next time.